Deputy Manager in Netafim Irrigation India Private Limited, Vadodara. He is post-graduated from Navsari Agricultural University. He served in NAU for 2.5 years as a senior research fellow, and since last 12 years, he is serving in Netafim Irrigation Private Limited, Vadodara. He possesses expertise in soil-plant-water relationship and agronomical aspects of field crops. I request you, sir, to please start the session.
Yeah, thank you, Ayushi. Before we start, I will just share the screens, and after we will start the sessions. Yes. I'm thanking to Dr. Gautam and Anand Agriculture Universities giving me and my company to serve you as an expert topic regarding of the decision support system and advance in soil and plant water-based micro-irrigation scheduling. Before starting, I will go through the basic concept of the irrigation scheduling. Then after we will move of decision support system, that is the totally artificial intelligence and automatic irrigation and fertigation system. We will discuss further on. Before that, we will start the basic concept of the irrigation scheduling and fertigation. So what is the advantages of the irrigation through drip irrigation? So mainly everyone knows that's the main maintain the field capacity. You know, the plants are working in basically in the field capacity situation. If the soil may be fully irrigated, means the saturated the soil, the plant doesn't not any activities. Same plant does not do the any activities, so the stop the nutrient uptake by the plants. So advantages of the drip irrigation with fertigation is suitable for the stop nutrient loss, better aeration in soil and plants, constant nutrient uptake. We will continuously serve the nutrient to the plants. Ultimately, earlier Ran sir and the dean of the college earlier taking the detail of the benefits and what is the criteria of the irrigation tables, means the water table in Gujarat and total India's area. So we through the drip irrigation, definitely we save the water, also saving the energy, and ultimately we get the better growth of the plants and we get the maximum benefits from the plants and increasing the increasing the our produce. So how we calculate the irrigation requirements? If you know, and maybe all of we heard the rainfall we measure in or inch. So here I giving the example 1 of water depth of the particularly in 1 hectare land. So here you can see the 1 hectare means the 100 meter and 100 meter, that is the 10,000 square meter, it is the 1 hectare, and I will fill the water in 1 So the equation you may know, the area is equal to length into weight, that is the 100 by 100, that is 10,000, and I put means the fill the water 1 So here we put the simple equation 1000 is equal to 1 meter. So 1 is equal to how? It's the simple calculation and we get the 0.001 meter. Now we convert meter into So volume equation, all we know, volume is equal to L into length into weight into height. So here we put simply 100 by 100 into 0.001. All figures are in meter, and the final outcome, that is the 10 meter. This is the 10 meter cube. So again I will derivative in liters. So simply 10 into 1000. So the requirement of 10,000 liters. That is simply say that the 1 mm rainfall comes in 1 hectare. So the total volume of the water, that is the 10,000 liter, we will receive in particular area. So this is the 1 mm equation, might be clear very much in next slide. Here simply 16 meter square is equal to 1 mm. So here you can simply calculate area into mm. So calculator the quantity of the water in liter. Here 4000 meter and 2.5 mm. So 4000 into 2.5 is equal to 10,000 liter. So this is the simple calculation. Area into mm is equal to liter. And if you calculate the area, so liter divided by mm, it is calculation, and liter divided by area is equal to mm. So this is the basic calculation of the water. So now we focus how much irrigation will do for the plants. So it is the simple, plants remove the water through stomatal activity. Everyone we knows the plants take carbon dioxide and takes the oxygen, but that is not release the oxygen. Plant release the water plus oxygen, that is the H2O. So the quantity of the water removed by the plants, that quantity we will fill and giving to the root plants by root through in root systems. So how plant activities, here you can see in the video, early in the morning sun is rise, and that the evaporation will starting on the through the stomata. So we will just calculate the how much quantity of the water removed by the plants, that's quantity of the irrigation we will provide the plants. This is the simple plant activities animation, you for your better understanding how much and how water losses from the plants. So how calculate the crop water requirement? So basically here same way we can see in our videos and animated videos. Here the water losses as evaporation plus plant requirement of water. This is where fertilizer. Here I am giving the example of the banana crops grown in large scale under the optimum soil water condition and achieving of the full production under the giving the climatic condition. So the evaporation of the water, that is the crop water requirement. The amount of the water required to the compensate the evapotranspiration from the crop field is defined as a crop water requirement. It is the crop water requirement. How it calculate? So the crop water requirement calculation is equal to ETC is equal to ETO into KC. ETC means the crop water requirement, which we will find ETO. ETO means reference crop evapotranspiration, and reference crop evapotranspiration calculated by the EPAN into KPAN. EPAN, that means the pan evapometer reading, and into KPAN means the crop factor. So this is the equation. We can calculate the crop water requirement, that is the ETO into KC. So basically crop water requirement calculation by the evapotranspiration demand at the atmosphere into crop water requirement, that is the exact we will get the crop water requirement. So before that we will go with the ETO, how we calculate the ETO. So here ETO is calculated by the standard pan evapometer. There is a two different method. One is the evapotranspiration and second one is the barley credit method. So basically we calculate on basis of the evapotranspiration. So it is a simple pan. Everybody look like that. It is the standard 25 centimeter deep and 120.7 centimeter radius. So this is the standard USWB class A pan evapotranspiration, and we fill with the water, and after 24 hours, every 24 hours we can get the data, that is the EPAN data, per day. So here we can get the evaporation data. Here I get the Anand district area annually rainfall and EPAN evaporation data. You can maximum and minimum temperature, humidity and EPAN data What is the exact EPAN for the particular month? So that after receiving the pan evaporation data, we calculate the EPAN data by simply one method, that is the wind, what is the wind speeds and what is the pan evaporation green crop area. Basically green crop, how much vegetation is near to the pan evaporated. So basically in Gujarat, average K pan is 0.70. We can roughly calculate 0.75 as a constant K pan data. So basically here I give one example of the mango crop. The crop coefficient means the Kc factor is in first stage, that is the 0.15. Then when as crop means plant height and development will be occurs, the Kc value will be increased, that is the 0.2 to 0.4, 0.4 to 0.5 and 0.65. So this is the crop Kc factors and crop coefficient data in particular. So crop coefficient, how we calculate, that is the Kc is equal to Wp by Wb. Wp means the width of the plant canopy width, and Wb, that is the bed spacing, what is the spacing between two plants, so two rows. So this is the equation for calculating the crop coefficient Kc. So in basically for understanding, here I put the one example of the banana crop. So calculate Kc is equal to plant shadow at sun at particularly on our head, that is the near about to 12 noon, and divided by the plant area. What is the plant area covered by the particular plant? Particularly you see in small size of the banana plant, the area and basically the distance of the plant growing by 6 feet by 6 feet, the area for the particular plant is 36 square foot. So simply here I put the shadows in lower. So the shadow size is the 9 square foot divided by 36 the area. So the crop Kc value for particular small one banana plants is 0.20, and as when the development of the plant doing and full canopy cover, the shadow area will be increasing gradually. So here you can see the area of 18 square feet divided by 30 square feet. So this is the basic calculation how we can calculate the Kc value. So this is now might be clear, the ETO into Kc is equal to ETC. On the basis of that, we put a irrigation schedule for the different crops. So here you can see the distance between two plant or distance between the drip line, that is the 1.8 meter, that is the 6 foot, and dripper spacing is 0.4 meter, and dripper discharge is 2 liter per hour. So the irrigation rate you can calculate here 2.78. So at the time of planting, and planting month is June, the EPAN data is 5.70 and KPAN earlier I was taught that is the in Gujarat we calculate basically at 0.75. So EPAN into KPAN we get the ETO value, and initial stage the KC value is 0.65. We already discussed how KC value we can get. So multiplication of ET and KC we get the ET. So here you can see 4 by 4.28 into 0.65. The ETO is the crop water requirement is 2.78. So when I run irrigation through by the drip, so my system irrigation rate is 2.78, and here the crop water requirement is 2.78 mm per day. So I just open my valve for 60 minutes, that is the 1 hour, and I will fill my crop water requirement in 1 hour. So gradually plant will be increased, and that is the KC will also increase, and EPAN depend on the climate condition, the EPAN data will be varies, and we simply calculate ETC and given to the farmer how much time you can run the system to fulfill the water requirement for those particular plants. So this is how we calculate the irrigation schedule. If you go with the flood irrigation, might be you can open your motor or run the motor every week or a 10 days interval near about to 1 days. So the total wastage of water might be more than 10 to 15 times compared to drip irrigation. So here crop water requirement curves you can see for the banana crops initially 0.5. At that time of the flowering and fruiting setting time, that is the KC factor value is 1.1, and then after reducing his KC value because of the maturity of the fruits are giving there, and then after it is the harvesting time. So the KC factor value and the KC value will be decreases. Here calculation of the crop coefficient, that is the initial is the KC is minimum, then after development time the KC value minimum to mid, and at that mid season KC value at mid, and then after KC late season KC end. Here some crop factor already given, basically initial stage, crop development stage, mid season and late season. Here the for example potato initially 0.45, then after 0.75, while in case of banana initially started is 0.65, but in potato initially start with 0.45 due to the canopy cover area by potato crops. So the 0.45, 0.75, 1.15, and then after KC end is 1.85. Second method I already told, but it is not popular, Banley Cadlit method. In this calculation, ETO calculated by P in bracket 0.46 T mean plus 8. So P derives from the mean daily percentage of annual daytime hour. T mean, the mean daily temperature, and T mean calculated by the T max by plus T mean, average maximum and minimum temperature, that is the T mean, and T max we get from the observatory minimum and maximum temperature data. So we can calculate minimum and mean temperature for particular days or maybe week or month basis. So example here I put P value is 0.29 and T mean is 21.5 degrees centigrade. So ETO is the 0.29, 0.46, it is a constant into 21.5, our T mean plus 8. So ETO is 5.18 mm per day requirement. But this method is not popular, and basically we calculate based on the EPAN data. It is a very complicated and lengthy method, so we cannot go with Banley Cadlet method. now how much irrigation we can give to the plant. So irrigation is the important role, because you can irrigate the soil, not irrigate the soil by drip irrigation, but you can also deliver the fertigation to the plant by the drip irrigation system. So you maybe know the root zone depth of the particular plant which you will be cultivated in your field. So here I put an example of the cotton field. So the cotton root system goes down near about 200 centimeter, and we define in different layers, like every 25 centimeter we divided in 100 centimeter. So in upper layer of 25 centimeter, cotton required total quantity of the fertigation and irrigation, 40% of the irrigation and fertigation absorbed by in upper 25 centimeter, then second 25 centimeter he receive 30 centimeter. So basically we at that time of irrigation by MIS, that is the drip irrigation system, we mainly focus our irrigation always means our moisture presence always be maintain of the depth of 50 centimeter while in cotton crops, because if we more irrigate, or maybe interval of the irrigation will be increased as our recommendation, so you will get more irrigation, and irrigation with fertilizer. So the quantity of the fertilizer and irrigation will be leached out from the effective root zone, and the benefit of the drip irrigation and fertigation may be not getting much better. So always keep in mind the particular root system. So at that time of irrigation, you should always maintain fertilizer and irrigation means quantity on particular root depth. The banana in cotton field, you can see the 50 centimeter is the effective root system, while in banana only 30 centimeter you can cover 90% of the root system. So if you go with the banana, you should maintain irrigation depth near about to 30 centimeters only, while in cotton the depth of the plant is 50 centimeters. So this point very much important for the irrigation and fertigation. Here I put one animation for the length of irrigation cycle. You can see when I start irrigation in 1 hour, you see the depth of the water, how much depth will be going on. Then after again 1 hour, it is covered to the our effective root source system, and then after again you will run, so the water and fertilizer both are leached out. Here the movement of the soil depend of the soil's structure. Here you can see the sandy loam soil, and here the clay soil. So at that time interval you can see 50 centimeter, and if you run the 24 centimeter continuously, drip irrigation will run out. How wetting pattern you can see in sandy loam, it is just like a radish or carrot like that, and while in clay soil the capillary movement of the water is increase more compared to the sandy loam soil. So it is depends on the your type of soil structure. Here you can again see the clay loam and sandy loam. In 4 hours you can see in clay soil 4 hours the bulk quantity below the depth is the 60 centimeter, that is the 2 feet, while you get 4 hours while the type of soil is sandy loam, you can reach 60 centimeter in only 30 minutes, while in clay soil that is the interval is 4 hours. So irrigation scheduling and irrigation interval depends on the soil structures. Sorry. Here, we all knows the soil pores. So, depend on the pore particles, you can see the how wetting pattern done in time interval. Here, we run the drip irrigation system for the 1 hours, and wetting pattern you can see the bulb circular pattern you can see, and then after in particular this size both area is field is same, but the operating wall is different. In particular this area run system for 1 hour, and this area run system for 2 hours, and same sand means soil structure is same, but after 1 hour and 2 hour you can see the wetting pattern in field. Normally in flood irrigation we fill the field and cover the soil with full of lots of water. What happen at that time? The field is fully saturated. There is full of water. There is no space of the air. But at that time, in this condition, the plant doesn't work well. Plant works while air particles present in the soil. You can see this is the situation, that is the field capacity. In this situation you can see the soil particles, air also present are there, and water is also there. This is the field capacity, and this is the, you can see the no presence of the water, only you can just water connected with the soil particles and full of water. This condition, it is a permanent wilting point. We already know about the saturation, field capacity and permanent wilting point. So while we get in flood irrigation, what happen is that, so earlier we put the flood irrigation, so initially 4 days the full of water is there, and that is the situation is called saturation. Then after some water will move, evaporate, and some will be leach out in the field. The situation comes, that is the field capacity, and this situation the plant will work good. And then after 8 days the field will losses of the water and only air will be there. So this is the wilting points. So while we irrigate on flood irrigation every 12-day interval, so only 4 to 5 days are there when plants are working good in condition. Earlier 4 days and after 4 days, that is the 8 days where the plant suffer from the excess of the water or maybe less of the water. While in drip irrigation, what happen in flood irrigation we can see on some animated video. Here you can see the day 1 you fill the full soil with water. What happen is that the total area will be covered by the water, and after 1 day 2 days some water may be evaporate or maybe leaching down. After 7 days you can see the evaporation process will be continued, but no presence in the field. And after 14 days you may find there is no water and your plant will be lost out. At that time this condition will we talk like that permanent wilting point. Wow. And what happen in drip irrigation, you irrigate daily, so there is no any saturation, no wilting point. Every day you create the field capacity and plant will work good in field capacity. So there is no any saturation and wilting point in drip irrigation. But here I one point added, some of the farmers will run drip irrigation system through all the nights. That is the 8 hours power schedule in Gujarat. So farmers go with field and open all the walls and run the motors and back to the home and sleeps in nights. So the whole nights irrigation going on at that time, the saturation will going on. So here I insist to all of you, run the system as per requirement of the crop, and we will calculate the irrigation schedule based on the crop and all the scientific calculation method. So what exact done in irrigation schedule of with drip irrigation, here you can see continuously we run the drip irrigation system. So continuously our irrigation means water is present in active near to the active root zone. So all days activities are going on and plants works properly evapotranspiration. If evapotranspiration process will good, so plant will absorb maximum nutrient which we will deliver to the roots. So here the basic fundamental between the flood irrigation and drip irrigation. Now I go with some here we can calculate how design the irrigation schedule. But recently last year we launched our product, that is the DFS. We normally called him digital farming solution, and basically work on the AI base. I think Ran sir already discussed about the automation system, how it's work. So what is the automation? Automation is nothing but the run your water pump, fertilizer pump, and wall. Three inputs we run by automatically by the controller. It is the automation. What is automation? Automation is nothing but it's a regularly, repeatably, and accurately activity done by the controller system and open flexibility. Here you can flexible with the different crop model, different fertigation schedule. Here you can also system operation as per electric schedule you have, maybe in night or maybe in morning. If you have different motor, it means that is you have different water source, that is one motor source is away from the 1 kilometer and second one is both water source distance between 1 kilometer. You go with the automation, you can run both pumps, more than one or two or multiple pump run by automation system. Increase water use efficiency and fertilizer use efficiency through EC and PS control, because you know the when the EC value will increase, your productivity will be decreased, and your soil pH will plays very important roles for the development of the plant. So increase water and fertilizer use efficiency. Also you save the labor cost in greenhouse or maybe in glass house or nurseries. You can also control your climate situation by automation, improve quality and consistency of crop by automation. Ultimately you get the increase your products produced and cost effectively by the automation. One more thing, you can also add monitoring and data storage by automation system. So I am proudly say that the NetBit, our product name is NetBit MCU. So the NetBit is only irrigation and fertigation system with control irrigation system, and it does done all three parameters, that is the sensoring and monitoring base. Second one you can do with the analysis and post decision supports, and third automation and control. Here we proudly say like that the first irrigation schedule with brain, because we give the solution totally artificial AI based answer also say that. So AI based system will be coming in next couple of years. But since from last year we introduced our irrigation controller with AI based, artificial intelligence based. So here we just roughly how DFS components is presence is there. Two types of controller are there. This is the Netafim Junior, means Junior Pro, and second one is NMC Pro. And recently we add our AI based two controller, that is the Net MCU. Remotely, if you go with without wirelessly, and that is remotely, so you can connect remote terminal unit, that is RTU. And second, for small land holding area, we introduce small unit, that is net MCU 1. This is our total 4 controller, and we giving the solenoid valves and also giving the water meter. Water meter is required for the quantity based irrigation you run. So the water meter must be installed in your controller, with controller. And dosing system, you go with the single channel, that is our product is that known as 31. That is a one injector 30 injection channel with a dosing pump. Second one is fertigate, coming with the EC and pH monitoring and also inbuilt dosing pump, and 3 Venturi installed by default. You may also increase 3 to 5 Venturi in fertigates. For greenhouse and net house, we have 2 products, that is the NetaFlex and NetaZ. These 2 dosing system along with the controller, so you don't need to adopt controller. So this particularly these 2 product basically designed and available for the greenhouse. What is the digital farming system? So here earlier we discussed the controller, and this is the dosing system. So automated means control your pump, wall, fertilizer by automation. So how it's run? So here I just put a example. If you go with the net for small holding, near about up to 5 hectares land, net MCU 1 our controller, which compatible with 31 and 30 kit. So, but this controller does not work wirelessly. It should work on wire basis. So 6 output presence by default in net MCU, and net MCU 1 control on of work on time based, quantity based, and sensor based, with and without artificial intelligence model, and it having 16 outputs. While in go with net MCU, by default 16 output plus 18 expandable output you can add. Particularly you go with wirelessly, so net MCU control connectively remotely with RTU, and also dosing system you go with 31 single channel or 38 ECPH. This controller work based on time, quantity, and sensor parameters. And one net MCU means one controller join 24 RTU connection with only one controller. So this is the beauty, and RTU net MCU is totally cloud based and AI based controller. How automation system work, you may know. The for going with the automation system, there is a 3 type of the automation will be done. One is the irrigation only, so you need only controller for the irrigation control. Second one is the irrigation plus fertigation. At that time you go with the controller plus dosing unit. And third one is the advanced system, that is the sensor based system. So at that time you go with controller, dosing system, and some sensors. So here the simple output calculation. In output calculation, we calculate the bore well, means the water, and water meter, dosing pump, venturi means our venturies, how many venturies you will add up, and fill walls. So this is the output calculation. Input, what is the input? So input, you can see the ECPH sensor and all temperature humidity sensors are inputs calculation. How it works? So here you can see the field sensor sensing the data and giving to the RTU. RTU connect wirelessly with the MCU. MCU works and our cloud-based analysis system, and you can see on your mobile or desktop interface, and AI based again transfer the data to MCU, and MCU given to control the RTU, and RTU run your program. So this is the simple layout how automation works. This is the automation irrigation room design. Here you can your water source, then after your primary and secondary filter, here your controller, and this is the controller, and with the fertigate or maybe single venturi you put it here, and this is the typical irrigation room for the automation. How wiring is doing, if you can go with the wiring simply, the automation controller and dosing system, controller wire with your field wall and your irrigation design, irrigation wall, that is the your motor, venturi, filter. You can connect with the wire and run. You can fill your program in this controller and run the program minimum 15 days. So this is the wire net MCU, and this is the wirelessly. In wireless you can see the RTU will be there. There is no any wire connection, only your filtration unit near to the your controller, so that this controller will wirely your field or your sensor totally are wirelessly connected there. So solenoid valve you can see replaced by the manual valve and install our solenoid valves is there. This is the our first net bit one side install and running. You can see this is the controller, and 31 only one fertilizer injector venturi install, but using different three NPK solution with only one venturi. So this is the net bit one installation site near Navsari area. Third MCU one we already installed in Department of Engineering in Junagadh Agriculture University. NetBit one we already installed that and running smoothly. And this system run by Dr. Ran sir. Also we have installed fully automated with EC and pH controller and net MCU controller at Agriculture University Junagadh in Department of the Soil and Water Department, Engineering Department. This is the second one in Gir Somnath area installation photo. This is the weather station. This is the RTU installed in Junagadh Agriculture University. This is the weather station installed in Junagadh Agriculture University, and this is the different type of filter. This is our sand filter. This is advanced screen filters that we call it's screen guard filter. This is the sprinkling filter. So all filters are automated in Junagadh Agriculture University. Here, time I have some shorter time, and this require much more time for deeply understand. So here I close the automation section, and also here I play one small video clip. That is our new product install recently before 2 months. That is the FlexNet, which is a flexible pipe using instead of you can go with PVC or HDPE pipe. So we can see one small video clip that is the only 4 minutes. Then conclude my presentation.
मेरे किसान भाइयों नमस्कार। नए उत्पाद लॉन्च के इस अवसर पर मैं आपका हार्दिक स्वागत करता हूं। नेटाफिम कंपनी किसानों के लिए किसानों द्वारा इजराइल में शुरू की गई थी। किसानों के जीवन में उन्नति लाने के लिए सबसे नवीनतम एवं इनोवेटिव तकनीक लाना हमारी विरासत है। इस कड़ी को जारी रखते हुए आज मैं कृषक समुदाय के लिए एक टपक एवं फव्वारा सिंचाई क्षेत्र में अभिनव और क्रांतिकारी उत्पाद प्रस्तुत करते हुए गौरवान्वित महसूस कर रहा हूँ। इसे फ्लेक्सनेट कहा जाता है। फ्लेक्सनेट टपक सिंचाई एवं फव्वारा सिंचाई को सरल बनाने हेतु क्रांतिकारी उत्पाद है। इससे किसानी भी आसान होगी।
फ्लेक्सनेट पाइप एक संपूर्ण समाधान है जिसका किसान भाइयों को जरूरत थी। ड्रिप और स्प्रिंकलर को एक स्थान से दूसरे स्थान पर शिफ्ट करना, पीवीसी और एचडी पाइप का उपयोग करते समय ऐसी कठिनाइयों का सामना करना पड़ रहा था। फ्लेक्सनेट इन सभी समस्याओं का जवाब है। संक्षेप में यह आपकी खेती को सरल बना देगा। यहाँ इस पर चर्चा करने के बजाय चले हम देखते हैं खेत में कैसे काम करता है।
नमस्ते किसान भाइयों। बुरहानपुर जिले के भोपनार गांव में हम नेटाफिम की ओर से आप सभी का हृदयपूर्वक स्वागत करते हैं। हम बड़ी खुशी के साथ आप सभी का परिचय एक रेवोल्यूशनरी प्रोडक्ट के साथ कराना चाहते हैं। भारत में पहली बार पेश करते हैं नेटाफिम फ्लेक्सनेट पाइप। फ्लेक्सनेट पाइप से खेती करना होगा अब और भी आसान। चलिए अब हम आपको लेकर चलते हैं उदय महाजन जी के खेत में और विस्तार से जानते हैं फ्लेक्सनेट के बारे में। फ्लेक्सनेट वजन में हल्का, कॉम्पैक्ट, लचीला और मजबूत पाइप है। पीवीसी की तुलना में इसे कहीं भी लाना ले जाना बहुत आसान है। फ्लेक्सनेट पॉलीप्रोपिलीन मटेरियल से बना है और इसकी अनोखी बुनाई तकनीक इसे मार्केट के अन्य उत्पादों से ज्यादा बेहतर बनाती है। ये पाइप वॉल्व्स, ड्रिप लाइन कनेक्टर्स, पाइप कनेक्टर्स और पंक्चर किट के साथ आपको मिलती है। फ्लेक्सनेट को इंस्टॉल करना काफी सरल है। इसके लिए आपको नाली खोदने की जरूरत नहीं पड़ती। पाइप कनेक्टर्स की मदद से इसे हेड यूनिट के साथ सीधा जोड़ा जा सकता है। फिल्टर्स और वेंचुरी इंजेक्टर की सहायता से पानी और खाद खेत तक पहुंचाई जा सकती है। फ्लेक्सनेट को 2 लोग आसानी से खेत में बिछा सकते हैं। मेन लाइन में पानी के बहाव को वाल्व से नियंत्रित किया जा सकता है। फ्लेक्सनेट 2, 3, 4 और 5 इंच के डायमीटर में उपलब्ध है। सब मेन लाइन के आउटलेट 2.5, 4, 5 और 6 फीट के विभिन्न अंतर में आते हैं। इसलिए इसे सभी फसलों में बड़ी सरलता से इस्तेमाल किया जा सकता है। ड्रिप लाइन को फ्लेक्सनेट सब मेन पाइप से केवल रिंग और ड्रिप लाइन कनेक्टर से जोड़ा जा सकता है। अगर किसी आउटलेट को इस्तेमाल न करना हो तो इसे फ्लैट प्लग से बंद किया जा सकता है। एंड कैप से सब मेन लाइन का आखिरी सिरा बंद किया जा सकता है और सफाई करने के लिए उसे खोला भी जा सकता है। अब फ्लेक्सनेट का ये रेवोल्यूशनरी सिस्टम खेत में खाद और पानी देने के लिए पूरी तरह से तैयार है। पानी का दबाव कम या ज्यादा होने पर भी फ्लेक्सनेट पाइप टेढ़ी नहीं होती। ड्रिप इरिगेशन सिस्टम सही तरीके से चलने हेतु पर्याप्त प्रेशर होना बहुत जरूरी है। फ्लेक्सनेट काफी मजबूत पाइप है और इस पर बाहरी वातावरण जैसे कड़ी धूप, बारिश और दबाव का असर नहीं होता है। किसी कारण से अगर ये पाइप पंक्चर हो भी जाए तो इसे बहुत आसानी से रिपेयर किया जा सकता है। सिंचाई होने के बाद इसे बड़ी आसानी से समेटा जा सकता है। इसे आप अपने घर में कहीं भी बड़ी आसानी से रख सकते हैं क्योंकि यह बहुत ही कम जगह में समा सकती है। आइए जानते हैं उदय जी की राय फ्लेक्सनेट इंस्टॉल करने के बाद।
मैं करीबन 8 या 9 सालों से खेती कर रहा हूँ। मुझे सबसे अच्छी बात लगी कि पाइप के पास में जो पहले नंबर का जो प्लांट है उसके पास में जो डिस्चार्ज मिलता है वही डिस्चार्ज एंड कैप पे मिलता है। अगर वेरिएशन नहीं आता है प्लॉट में तो केले का कटिंग बहुत अच्छा आता है और वेट में जो एवरेज आता है पूरे प्लॉट का वो सबसे बेस्ट आता है। फ्लेक्सीनेट पाइप जो है ना, लेबर का खर्चा तो पूरा ही बचा रहा है। अगर मैं कहीं से परचेस कर रहा हूँ, बुरहानपुर जैसा यहाँ से पास में गिरता है, तो मैं उसको बाइक पे भी ले आ सकता हूँ। और पीवीसी का ऐसा कोई बिना ट्रैक्टर का नहीं आ सकता है। और बिछाने में भी वही दिक्कत है, पाइप को उठाओ, उसको बिछाओ, उसके सेटिंग करो, प्लांट के पास में टेकअप आना चाहिए, कपलिंग वगैरह। और इसका फ्लेक्सोनेट का ऐसा है कि अपन डायरेक्टली बिछा दो, माप तो उसका फिक्स है तो कोई दिक्कत ही नहीं है। डायरेक्टली आप टेकअप फिट करो, नली ज्वाइंट कर दो, उसमें पानी चालू हो जाता है। और उसका एक फ़ायदा है कि पानी चालू करते करते अपने को 2 या 3 दिन लग जाते हैं पीवीसी में। फ्लेक्सोनेट में 1 ही दिन में पानी चालू हो जाता है। जब क्रॉप खत्म हो जाती है तो पाइप निकालते हैं, उसको रखने के लिए बहुत दिक्कत होती है। और फ्लेक्सोनेट का ऐसा है कि आप उसको फोल्ड करके कहीं पे भी एडजस्ट कर सकते हो।
फ्लेक्सनेट को आपके पास पहुंचाने के लिए हमारे पास भारत में कर्मचारी और डीलरों की अच्छी संख्या है। आप ईमेल, टोल फ्री, मिस कॉल और व्हाट्सएप नंबरों पर हमारा संपर्क कर सकते हैं। आप सभी किसान भाइयों ने नेटाफिम के समाधान एवं उत्पादनों पर हमेशा एक अटूट विश्वास दिखाया है, जिससे हम अभिभूत हैं। आशा है कि यह विश्वास जारी रहेगा और हमारे रिश्ते को मजबूती प्रदान करेगा। धन्यवाद। आइए अपनी खेती फ्लेक्सनेट के साथ सरल बनाएं।
वजन में हल्का, कॉम्पैक्ट, लचीला और मजबूत फ्लेक्सनेट रेवोल्यूशनरी पाइप को जल्द ही अपने खेत में लगाएं और खेती करना आसान बनाएं।
Thank you.
Thank you so much, sir, for this very informative session. You have explained the topic very nicely.
Okay.
I think our participant digested this topic very well, so there is no doubt or questions from the audience sides. I once again thank you, sir. Thank you so much.
Thank you, Jim.
Thank you. Thank you, Prashant.
Thank you, Gautam. See you soon. Bye.
Bye.
Now moving ahead to our next technical session. Let me first introduce our next guest speaker, Dr. K.C. Patel, sir. He is currently working as Associate Research Scientist at Micronutrient Research Project at Anand Agricultural University, Anand. He has 30 years of experience in soil science in different cadre. He received 15 awards, published more than 50 research papers, and handled more than 15 other agency projects. He has successfully guided more than 15 MSc students and about 6 to 8 PhD students. With this, I request you, sir, to start the next session. Please, sir.
Okay. Good afternoon, everybody. Today's webinar theme on advances in micro-irrigation and fertigation for improving water use efficiency and crop productivity. Since morning, different speakers talk about the micro-irrigation and different aspects. My topic is concepts and techniques of nutrient management for enhancing water and nutrient use efficiency. So it's a practical approach of the micro irrigation system. So what is nutrient management? So nutrient management is the science and practice directed to link soil, crop, weather, hydrological factors with cultural operation, irrigation, and soil water conservation practices to achieve the optimum nutrient use efficiency. Apart from this, crop yield also, crop quality and economic return, while reducing offsite transport of nutrient, particularly fertilizer. Those may impact on the environment. It involves matching a specific field, soil, climate, and crop management condition at the right rate, right source, right timing, and right place. This is known as the 4R nutrient stewardship of nutrient application. So, what is nutrient use efficiency? Why is nutrient use efficiency required? In Indian agriculture, import of fertilizer value about 35,000 crores. This is data of the 2012-13, but even more value even there. And the losses of nitrogen fertilizer, due to the losses of nitrogen fertilizer, we are losing around 3,000 crore rupees per year. If 1% increase in nutrient efficiency, we can save the 10,000 million rupees. Apart from this, human health is also issue. As per the example in Punjab and Haryana state, the groundwater contamination of the nitrate nitrogen reached beyond the 20 ppm nitrate nitrogen. This is also more concern because of the infant are more affected due to the nitrate nitrogen. Also, nitrogen use efficiency more important because of the year by year decreasing the response of NPK, particularly in our Indian agriculture, and fertilizer consumption increased manifold. But towards the fertilizer consumption, the increase in food grain production increase only to 3 to 4 times. So this is also more concern for the efficient use of the fertilizer. Looking to the data of the world, different countries, in India, the nitrogen use efficiency decreased around 60% over the 20 years, 20, 30 years. In rest of the country, looking to the data, the nitrogen use efficiency increased. So this is also one of the important aspects, how best we can use the nutrient in crop production. So to meet the social demand of food, at a global change, there is a global change challenge as a recent estimate indicated that the global crop demand will increase by 100 to 110%. Another scientist also estimated that the world will require more than 60% cereal production. Also estimated that the double food required within 30 years of era. So Food production require 100% or more than 30%, 50%. So to increase the crop production and to meet the demand of the society, huge efficiency of nutrient is critically important concept for evaluating crop production system and can be greatly impacted by fertilizer management as well as the soil plant water relationship. Nutrient use efficiency also indicate the potential for nitrogen losses in the environment from cropping system to meet the increasing societal demand of the food, fiber and fuel. So what are the objective of the nutrient use and nutrient use efficiency? The main objective of the nutrient use is to increase the overall performance of the cropping system by providing economically optimum nourishment of the crop while minimizing the nutrient losses from the field and supporting all agricultural system in a sustainable manner and maintain the soil fertility or soil quality component. So nutrient use efficiency also address same but not all aspect that performance. The most valuable nutrient efficiency improvement are those contributing the most overall cropping system performance. Fragile lands usually support system with lower nutrient efficiency and at the same time the nutrient rates increase toward the optimum productivity continue to increase but at a decreasing rate, but nutrient use efficiency typically decline. So the extent of decline will be determined by right source, right time and right place factor and other cultural practices as well as the soil and climatic conditions. So what are the causes of this low nutrient efficiency? Because of, here we can see the nitrogen efficiency only 30 to 50%, while phosphorus 15 to 20, potassium 70 to 80%, sulfur only 8 to 10%, and micronutrient only 1 to 2%. So to increase the nutrient efficiency also there are some of the aspects. So what are the causes of the low nutrient efficiency of nitrogen? The immobilization, volatilization, denitrification, leaching. In case of phosphorus, fixation with the iron, aluminum and calcium. Potassium fixed with the clay lattice. And micronutrient also fixed with the clay lattice. And sulfur, leaching of the sulfur with the downward movement of water. So these are the causes of the low nutrient use efficiency. So what are the causes of the low nutrient efficiency? So our Indian soils are low organic carbon and even the degraded soil. Susceptibility of nitrogen fertilizer to losses by various mechanisms. Imbalanced use of fertilizer. Poor management for secondary and micronutrients, especially sulfur, zinc, manganese, iron, boron. Use of high analyzed fertilizers like urea and DAP and inadequate use of the organic manure and inappropriate rate and time method of the application of fertilizer. So these are the causes of the low nutrient use efficiency. So what are the intervention of for increasing the nutrient use efficiency, particularly in field crops? So there are two types, soil-based and plant-based. In soil-based, rhizosphere management, soil chemistry modification, use of controlled release fertilizer, and source, method, rate, and timing, use of the nitrogen inhibitors, use of even organic manures, and water management. In case of the plant-based intervention, the crop management practices, crop rotation, crop residue, crop manuring, green manuring, use of the nitrogen efficient species, biofertilizers, genotypes, and customized fertilizer. So here we deeply go discuss water management, how best water management helpful in the increasing the nutrient use efficiency. So there are four type of the micro irrigation system in the water management: drip irrigation, sprinkler irrigation, fogging, and bubbler. So micro irrigation is the frequent application of the small quantity of water on or below the soil surface and drops in a tiny streams or miniature spray through emitters. System operating at low flow rates and low pressure. Localized distribution of water, normally in a proximity of the plant root system, that is rhizosphere. Maintain the ideal moisture condition for optimum plant growth. Even nutrients can also be applied precisely as per the plant need. So these are the characteristics of the micro irrigation. So with the irrigation, fertilizer can be applied. So it's a fertigation. So productivity of crops is also based on the effective utilization of water and fertilizer along with other nutrients also. Provision of optimum quantity of water and fertilizer in most cost effective efficient manner is the challenge facing the farmer for profitable farming. Now the answer is to challenge the fertigation, where both the water and fertilizers are delivered to the crop simultaneously through micro irrigation system. Fertigation means the application of fertilizer through irrigation system, referred as the fertigation. And with the use of the fertigation, we can increase the 25 to 30% of the crop yield, even improve the fertilizer use efficiency. Application of the fertilizer is more accurate and uniform. Nutrient can be applied as per the plant requirement. Minimize the nutrient losses by volatilization or immobilization. Nutrients are also immediately available to plant because of the localized placement, and saving in time, labor, energy helps in effective weed management program also. So there are two type of dosification: quantitative and proportional dosification. In quantitative, the concentration change every time, but in case of proportional dosification, constant concentration throughout the field and throughout the time. This is the advantage of the proportional dose. What is the difference between fertigation and fertilization? The fertigation is the fertilizer applied according to the need for nutrients, following the uptake of the crop, nutrient uptake of the crop. While in case of the fertilization, plant get larger dose of fertilizer than they require at the time it is applied. Losses more occur in case of fertilization. So here this is the comparison between the surface irrigation and drip irrigation, particularly nutrient application. So in drip fertigation, the uniform nutrient placement in the rhizosphere, while in case of the surface irrigation, surface placement is more, or sometimes the leaching of the nutrients are more. So this is the comparison between the drip and surface. And suitable fertilizer for fertigation. So it should be the higher nutrient content, the readily available to the plant also, fully water soluble at field temperature condition, no clogging of filter and emitters, low content of insoluble compatible with other fertilizer also, minimum interaction with the irrigation water, and no drastic change of water pH. This is the characteristics of the fertilizer suitable for fertigation. So which nutrient can be fertilized? So nitrogen is the most commonly used nutrient through the fertigation. Almost all nitrogenous fertilizers are suitable except ammonium sulfate, which cause precipitation of the calcium sulfate and magnesium sulfate. Urea is well suited for fertigation. It is readily dissolved in the ionic form and even does not react with the substance dissolved in water. Even liquid fertilizer are also best for the fertigation. Fertigation using granular fertilizer pose severe problem like differences in solubility in water, compatibility, and other problem of filtration of undissolved fertilizer. So the fertilizer use efficiency, particularly in soil application, the soil application for nutrient having only 30 to 50 percent nitrogen use efficiency, while with the use of fertigation, we can increase up to 90 to 95%. In case of phosphorus, 20, and with the use of fertigation or micro irrigation system, now use efficiency increase almost double. In case of potassium also, 50 to increase up to the 80%. So these are the benefits of the micro irrigation system. This chart indicates the green color indicate the compatibility of the fertilizer with other fertilizer. Yellow is the less limited compatibility. Red is the very limited compatibility. So here urea is the more compatible fertilizer and even water soluble fertilizer also. So granular fertilizers are not compatible with other fertilizer, particularly in micro irrigation system. So another system or type of the micro irrigation system, the foliar application. Foliar application is the technique of feeding plant by applying liquid fertilizer directly to their leaves, and this foliar fertilization is generally used for better management of the various nutrient status, for growth, or to correct the deficiency quickly, to improve the disease resistance also, for frost mitigation also, and to increase the crop quality also. So the mechanism for the foliar absorption, we assume that the nutrient enter the leaf only via stomata, and since the stomata are mostly situated on the underside of the leaf, for a rapid and complete uptake of foliar fertilizer, it is necessary to spray both underside of the leaf and upper surface of the leaf as evenly as possible. So these are the commonly used fertilizer for fertigation. We can see here the solubility of the ammonium nitrate even more than 1800, and followed by the urea more than 1000, followed by the ammonium sulfate also. So these are the solubility of the fertilizer we can use in the fertigation, and some specialty water soluble fertilizer also uh, available in the market in a different grade, NPK grade, 15 15 15 20 20 20 19 19 90, 18 18 18. So there are different NP grades, water soluble grades available in the market that can be used for as a water soluble fertilizer, and even micronutrient multi micronutrient mixer grade also nowadays available in the market, government notified grades that also water soluble, and we can use to correct the deficiency of the micronutrient, particularly zinc, iron, and sometimes both deficiency in standing crop. So we can spray at the rate of 1% this multi micronutrient grade, particularly notified by approved by government of Gujarat. So in case of nutrient deficiency, the nutrient deficiency at low level, the yield also decrease, but is reached up to the optimum level. Then the crop productivity also increase up to the optimum, and the use of the nutrient, particularly in the form of fertilizer, increase with above the use efficiency. The use efficiency decrease, but the productivity remains same. So use efficiency decrease, again it will the causes the another problem, leaching of the nutrient, or particularly any nutrient in the groundwater create the problems. So micro irrigation, we can see here the it save the water, fertilizer also, labor also, and lesser yield also, higher yield and higher income. But with the use of the irrigated area, we can increase the with the use of the micro irrigation, they increase the area more than 50%, income also increase more than 50%, yield also increase more than 40 to 45%. Capital cost decrease, cost of labor also decrease, energy use decrease. We can water apply also, we can save the water. So the irrigation efficiency increase with the micro irrigation system. The data they indicate that at the experiment conducted at different location using different crop as a test crop, the fertilizer saving in percentage, we can see here the 20 to 50% or even 60% fertilizer quantity save with the use of the micro irrigation system or fertigation, and increase in the yield also up to 10 to 30%. Particularly in cereal, the potassium fertilizer recovery, the experiment conducted on cereal crop, particularly wheat, maize, rice, and here we can see the different scientists work on different potassium fertilizer recovery, and the average reported recovery of the potassium around 50%, and agronomical K efficiency around 7 to 8%. But on an average, the 30% recovery efficiency increase with the use of the micro irrigation system. So there are the different how to work out the nutrient use efficiency with the use of data on yield, nutrient content, nutrient applied, and other parameters. So there are 11 indices of the nutrient use efficiency, agronomical efficiency, then physiological efficiency, agrophysiological efficiency, apparent recovery efficiency. Even the formula also given in the slide. Utilization efficiency, nutrient efficiency ratio also, nutrient increment efficiency, partial production efficiency, economic nutrient use efficiency, nutrient harvest index also, partial nutrient balance PNB or nutrient removal ratio. So these are the 11 indices. We can calculate the nutrient use efficiency with the use of different parameters. Here the common nutrient use efficiency terms and their application, particularly practical application. Here we can see the partial factor productivity. So typical use of this indices is a long-term indicator. But in case of the agronomic efficiency, it's a short-term indicator for the impact of applied nutrient on the productivity. Also used as an input data for nutrient recommendation based on the omission plot yields. Partial nutrient balance is also a long-term indicator, and it can be useful when combined with the soil fertility information. Apparent recovery efficiency, it's a difference, is an also indicator of the potential of nutrient loss from the cropping system, and assess the efficiency of the management practices. Internal utilization efficiency, it evaluates the genotype of in a particular program, and value 30 to 90 range are common for nitrogen in the cereal and 50 considered as optimal. Physiological efficiency is research evaluated nutrient efficiency among the cultivars and other culture practices, and value ranges from 40 to 60 are common. So these are the indices practically applicable in different fields. Some typical levels or the lower levels of the NPK here workout for different indices, particularly for the cereal crops. So partial factor productivity, the lower level suggests that the response of soils over the less response of soil, and the over application of nutrients, while higher level suggests the nutrient supplies is likely limiting productivity. So likewise, agronomic efficiency, lower level suggests the changes in management practices, recovery efficiency in case of recovery, lower level suggests the changes in the management could improve efficiently, and that the nutrients are accumulation in the soil. And partial nutrient balance, the lower level suggests the changes in management could improve the efficiency, and soil fertility could be increasing at higher level. So these indices also indicate the typical practical application. So another term is water use efficiency. The 20% of the world croplands are irrigated under the scenario of the water and produce 40% of the global harvest. Irrigation multiplies yield of most crop by 2 to 5 times. But here in case of your India, the micro irrigation system, the around 12 million hectares area covered under the micro irrigation system, as compared to the other countries, other region countries, the irrigated area 71% under the micro irrigation. So here the water used by different crops, we can see here the alfalfa or pasture group of the crops require more water as compared to the other crops. And the at world level, water use particularly 70% under agriculture sector and industry at 22%. While the statistic of the water resources, you can see here the annual water availability around 2000, usable water 1123, and surface water around 690, groundwater around 433. So this water use efficiency usually calculated based on the grain yield of the or total biomass produced per unit of water consumed by crops, and the quantity of water consumed by crops is estimated according to the total amount of water used from the plant and soil surface in addition to that retained within the plant structure. The numerous management and environmental factors interact with the influence of the nutrient use efficiency, including plant water status. In the similar fashion, plant nutrient status can markedly influence water use efficiency also, and this water use efficiency described on various scale from leaf to the field. In its simplest term, water use efficiency refers to the ratio of yield to the water use during the crop growth. So water use efficiency provides a simple way of assessing whether yield is limited by water supply or other factor. Efficient and effective use of the either water or crop nutrient require that both be managed at optimum level for specific system. Adequate nutrient supply has shown improve the water use efficiency in several crops. So water use efficiency can be calculated by crop water use efficiency CWUE using the it is the ratio of the crop yield to the amount of water depleted by the crop in the process of evapotranspiration. And under field condition, the field water use efficiency, the ratio of crop yield to the total amount of water used in the field. So these two indices can be used for calculating the water use efficiency. So water in soil plant atmospheric continuum, why when the water apply into the soil, so there are losses of water in a different way. It retain in the macro and micro pores, leaching losses, even microbe use, evaporation also, removed by plant also, evapotranspiration, and if the plant also remove by the water also removed by plant in the terms of photosynthesis, transportation, and even transpiration. So more than 90% losses of water through the transpiration in the water. So therefore, the micro irrigation system is very much required to minimize the losses. So how? What are the status of the drip irrigation system in India? So we can see here the year by year from 1981. This is the data to 2019. The growth of the adoption of the drip irrigation system in India increased. So why this modern irrigation technology are needed? Because the productivity of the irrigated land is low compared to the with potential. Productivity per unit water is very low. Water availability for irrigation is scarce. Cost also for generating water source is ever increasing. Low water retention capacity of the soil. Micro irrigation will increase only the way the micro irrigation will increase the irrigation by covering large area. So micro-irrigation with fertigation will again also enhance the production per unit input in the nutrient wherever the poor, shallow and slopy soil. So these are the benefits of the micro-irrigation. And earlier we have discussed the drip irrigation also, the discovered in Israel. These are the engineering aspect of the drip irrigation. There are another type of the drip irrigation, subsurface drip irrigation also. We can use in the subsoil wherever the problem of the soil. Now here the type of the soil also very much affected in the drip irrigation system. So with the drop of the water on the soil, particularly in clay soil, the spreading of the moisture, we can see here the horizontal spread, but with the increasing the sand percent, the moisture content uh, vertically down, move to the downward, and along with the nutrient also lost with the water. So another type of the irrigation system, sprinkler system. It's a method of applying irrigation water which is similar to rainfall. Water is distributed throughout the system of pipe, usually pumping at pressure about 2 kg per centimeter square, and it is sprayed in the air and irrigated entire soil surface throughout the spray. And pressurized irrigation through device called sprinkler, and sprinkler usually located on lateral pipes. Another one is fogging or misting system, bubbler irrigation also. So efficiency, comparing the efficiency of the different irrigation methodology or system. So here we can see the flood, furrow, irrigation with flood, furrow, rainwater, overhead sprinkler, micro sprinkler, drip irrigation. So in flood irrigation, only 30 to 35% water use efficiency, and in case of the drip, 85 to 90% water use efficiency. So in some important field crops, the here we can see the finger millet having the highest water use efficiency, followed by wheat. And grouping of the some important field crops, so highest water use efficiency in case of the maize, sorghum, pearl millet, finger millet, and in medium wheat, barley, oat, and particularly low water use efficiency in pulse crops and some oilseed crop also. So this is the comparison of the water use efficiency, the transpiration versus the grain yield. The transpiration increase, water use efficiency decrease. And though with the increasing the water use efficiency, biomass or grain yield also increase. So this is a positive relationship. So there are different management approach to improve the water use efficiency, particularly water saving, terracing, and control farming, mulching, and plant mineral nutrition. In water saving, on-farm water use efficiency can be improved by moving to a more efficient irrigation system. So that is, there are three main type of system: flood, furrow flood system, sprinkler, and drip. With the drip system being the more efficient than sprinkler, and the sprinkler irrigation being more efficient than furrow irrigation. Terracing and contour farming, here wherever the undulated area or the slopy land, we can use the drip system or sprinkler system and use the water use efficiency. By mulching, particularly straw mulch, plastic mulch, among these straw mulch are more efficient. The straw mulching can be easily implemented by local farmers because the material is easily available, low cost also, and with the decomposition, nutrients are also added in the due course. Plant mineral nutrition, fourth type of the approach. Here we know that the 17 essential nutrients are required for plant growth and development, and it is categorized into macro, secondary, and micronutrients. And with the increasing evidence that the mineral nutrient status of the plant play a critical role in enhancing the water use efficiency by proper nutrition. So here's some example how the nutrient, particularly nitrogen, increase the water use efficiency of the plant. So we know that the nitrogen uptake by the plant in the form of nitrate and ammonical form, and this nitrogen increase the protein content, also increase the membrane stability, plant biomass, and increase the membrane polarization also. And side by side, it maintain the chloroplast and lipid biosynthesis, some biochemical parameter also, and ultimately increase the reduce the oxidative damage, and ultimately increase the photosynthesis rate of the plant, and by this way increase the water use efficiency of the plant. Likewise, phosphorus improve the root growth and maintain the high leaf water potential, also maintain the cell turgidity and water nutrient uptake, improve the assimilation and increase the stomatal conductance, and also increase the photosynthesis rate by efficiently increasing the all parameter and use the water use efficiency. Potassium, we know that it maintains the high pH in the stomata, decrease the loss of moisture, decrease the transpiration also, and enhance the root growth, and ultimately also increase the maintain the chloroplast membrane, and enhance the photosynthesis, also maintain the osmotic potential also. And by this way, clubbing this all efficient use, it enhance the water use efficiency. In case of the zinc, among the micronutrients, increase the oxygen levels. It also part of the coenzyme, decrease the activity of the membrane bound oxidase, and also increase the production of the tryptophan, decrease the ROS generation, and ultimately it take parts in the enzymatic activity also, and enhance the root growth and enhance the activity of the some biochemical parameter, and by this way it also enhance the water use efficiency. So some reports review have gone through some research paper and some evidence on the basis of research how best the micro irrigation can increase the water use efficiency or nutrient use efficiency. So here we can see the drip irrigation system with the use of drip as compared to the conventional, the water saving can be 29 to 30%. In case of sugarcane, banana 35%, and tomato 32%. In case of the experiment on maize, the 100% RDF through the deep fertigation, they increase the grain yield, also increase the water use efficiency, and they also uh, increase the water, save the water. In case of the cotton, the experiment conducted, the drip irrigation system with 0.8 CP, the total saving of the water around 14%, and due to this, not only the saving of the water, the yield also increased with the drip system with the 0.8 CP, and in the case of the sprinkler, micro sprinkler system also, the 80% P increase the yield, and also water use efficiency. The different scientists work on different station on different crops. Altogether, 30 to 50% water saving reported, and simultaneously the crop will also increase 20 to 50%. In case of the brinjal vegetable crop, the 25% dose decrease with the drip irrigation system, and water use and nutrient use efficiency also increase. Nitrogen and potash use efficiency also increase with the drip irrigation system, and again the in case of cabbage also. With the reducing the 25% dose of the recommended dose of the nitrogen and potassium at daily interval, the NPK efficiency increased highest as compared to the other treatment. Also similar result in case of the PGNP, in case of cotton also. Now, in case of the rice, higher water requirement, the 100% RDF through the drip irrigation system with water soluble fertilizer, the highest grain yield recorded. In case of the potato, again the vegetable crop require the more water. So here the water use efficiency and nutrient use efficiency also increase. So these are the evidence of the micro irrigation, particularly drip system, how increase the crop yield with the water use efficiency and nutrient use efficiency. And in case of the yield and water use efficiency of wheat that require 6 to 7 irrigation, here we can see that the lateral spacing 60, the highest grain and flower yield recorded, and the water use efficiency also recorded highest along with the 100% nitrogen dose. In case of the cumin, we require very low quantity of the water, even that highest water use efficiency. In case of the wheat, again the 100% CP on 2 days interval, the 30% means nutrient efficiency. So these are the evidence of the how best the drip irrigation system can be utilized for efficiently utilization of the nutrient for the crop growth and development. So this from the ongoing discussion, it can be concluded that the fertigation through drip irrigation system is efficient and advanced technique. Drip irrigation at 75 to 100% RDA plus 0.8 to 1 PF, saving both fertilizer, approximately 40% saving of the fertilizer, and water, approximately 50% water we can save, as well as improving the crop yield. The 20 to 100% crop yield also we can increase with the use of the drip. And apart from this, quality also increase, use efficiency also increase, nutrient content and uptake also increase. So with the quality, or we can say the very nutritive crop will also increase. The drip irrigation system is observed to be economic, maintain the soil fertility also, earning high profit as compared to the conventional surface irrigation. The order of the irrigation efficiency, drip is more efficient compared to sprinkler as compared to the flood. So the nutrient management is essential in modern crop production system for improving the long-term sustainability. Judicious application of fertilizer at 4R, that is right rate, right time, right place, and right agronomical practices, targeting both high yield and nutrient use efficiency, will benefit the farmers, society, and even environment also. However, we must be cautious that the improvements in efficiency do not come at the expense of the farmer economy, viability, or the environment. And the management of the plant nutrients is very helpful to enhance the water use efficiency, reducing the detrimental effect of the stress. Among the plant nutrients, phosphorus, potassium, magnesium, and zinc improve in the physiological, biological, and metabolical processes in the plant and enhance the photosynthetic rate and ultimately increase the water use efficiency. So we should take the uh, nutrient management with these nutrients. So therefore, the nutrient management with micro irrigation system prove better for increasing nutrient use efficiency and water use efficiency. Thank you.
Thank you so much, sir. You have cleared our concepts about nutrient management. So we have received one question that is there any correlation in different parameters of nutrient use efficiency?
Hello?
Yes, sir. May I repeat the question?
Uh-huh.
Is there any correlation in different parameters of nutrient use efficiency?
ये बोल रहे आवाज ये थी।
Is there any correlation in different parameters of nutrient use efficiency?
Is there any correlation with nutrient efficiency and
Parameters of nutrient use efficiency.
hello? So there are different parameters affect the nutrient efficiency. So each and every parameter should be maintained for efficient nutrient use efficiency. If anyone is lacking or anyone is mismanaged, then ultimately directly affect to the nutrient efficiency.
Okay, thank you, sir. Once again, I thank you, sir, for this wonderful session. Now we are going to start our plenary session of this online seminar. First, I would like to welcome our chief guest of this plenary session, Dr. ML Gaur, sir, the convener, Dr. R.S. Pundir, sir, our guest speakers, Dr. K.C. Patel and Mr. Prashant Pancholi, our organizers, Dr. Gautam Patel and Dr. Y. Lad. In this plenary session, I welcome you all. First of all, I would like to request Dr. R.S. Pundir, sir, for his welcome address. Please, sir.
Hello.
Yes, sir.
Before we start, a very good evening to one and all. At the end of the day of online seminar on advances in micro-irrigation and fertigation for improving water use efficiency and crop productivity. At this platform, I welcome Dr. Gaur sir, our eminent speaker, Dr. K.C. Patel sir, and speaker is Prashant Pancholi from the Netafim Irrigation. So the formal inaugural event was presided by our Honorable Vice Chancellor, Dr. R.V. Vyas. He emphasized the judicial use of water, either for agriculture or other means. He stressed to encourage the farmers to adopt the micro-irrigation system in order to not only save the water, but fertilizers and energy too. He also advocated to encourage the farmers to use soluble and liquid biofertilizers, which are more suitable to use through micro-irrigation system. He also urged scientific fraternity to focus on enhancing water use and fertilizer use efficiency. In technical session 1, keynote lecture was delivered by Dr. R. Subbiah sir, Principal and Dean, College of Agriculture, Engineering and Technology, Anand Agriculture University, Godhra. He explained the scope of micro-irrigation system and crop performance prediction through micro-irrigation. He elaborated the efficient design of irrigation scheduling, considering the various affecting factors and field conditions. In the morning session, second technical session, Dr. H.D. Rak, Professor and Head, Department of Soil and Water Engineering, College of Agriculture, Engineering and Technology, Junagadh Agriculture University, Junagadh, described and elaborated the design of drip irrigation system for and fertigation in the various field crops. In third technical session, Senior Agronomist of Netafim Irrigation India Private Limited, Vadodara, Shri Prashant Bhai Pancholi delivered a lecture on decision support system and advances in soil and plant water based micro-irrigation scheduling. He also explored the recent products in micro-irrigation segment. He shared some examples and photographs of a success story of the farmers. In the last technical session, Dr. K.C. Patel, sir, research scientist, Micronutrient Research Unit, Anand Agriculture University, Anand, delivered a lecture on concepts and techniques of nutrient management for enhancing water and nutrient use efficiency. He explained the various factors that are to be considered for dosing methodology and application in order to enhance the fertilizer use efficiency. So hence, all the lectures were fruitful, and I hope that this knowledge and information will be helpful to farmers, young entrepreneurs, students, and faculty members as well. Thank you, everyone. Thank you. I will see.
Thank you, sir, for sharing the observation from this online seminar. Now I would like to request Dr. R.S. Pundi, sir, for his address. Please, sir.
Thank you, Aishi. Good afternoon to everyone. And at this plenary session, first of all, on behalf of our university family and on my own behalf, I welcome our chief guest, Dr. M.L. Gaur Sahab. Gaur Sahab, you are here. Are you listening me, sir? Aishi, Gaur Sahab is not here?
Yes, sir. He is connecting very soon.
Okay, so Gaur Sahab, I welcome Gaur Sahab. And also I welcome our other colleagues, Dr. Gautam R. Patel, who is also organizing secretary of this thing and who has taken the pain about this whole activity webinar in conducting this one along with the other colleagues. And I also welcome my colleague, Dr. Y.A. Lad, CCPI, HRD, and HP Cast. And of course, all the participants and the faculty associated with this project, and particularly to this webinar, and all the staff members of NHP Cast. I think all the sessions have been very well today, and our observations as well as the feedback received from the participant has been very good in this regard. And with these things, we are here to listen to observations, but more than that, Dr. Gol has already discussed these things. We are here to listen the address of our chief guest. He's a renowned scientist in this area who has done a lot of work in micro-irrigation. And we know that in all the advanced areas and important areas which can help the scientists and maybe the PG scholars, they are also important for the farmers. So I'm here to welcome once again our chief guest as well as to listen his address. Whether Ayushi, can I over to you or we shall wait?
Yes, sir. Our chief guest has joined.
Okay, okay. Dr. God, this is R.S. Pundir. Welcome you, sir, to this webinar. This is plenary session. Dr. Gautam, God Sahab is not linked, or maybe he's, you asked him, request him for unmute.
Dr. Gaur, sir, you are muted, I think. Sir, please unmute yourself.
Is it right now?
Yes, yes.
Yes.
Okay. Thank you.
Welcome, Dr. God. We welcome you once again.
Actually, I was on desktop, so I have shifted from desktop to mobile. So that's why. Sorry.
Okay. So, sir, once again, I welcome you on behalf of our whole family, AU, and on my own behalf to this plenary session as the chief guest. And we have already seen the lectures of the experts in this one-day webinar on micro-irrigation, and you are a renowned person who has done a lot of work. So we are here to listen you today as chief guest in this plenary session. Over to you, sir, and welcome.
Yeah. So nice of you, sir. So very first, I am very happy to address this very valuable function on a very important webinar on a burning issue of irrigation. You know, water is the core of research across the globe. Not globe, nation, world, village, person, all are crying for water. So under such a static era, we are passing through COVID. COVID is a static era. Under such a static era, we have done a very dynamic work. So dynamic presentations. I'm happy to see those presentations. And let me at the outset compliment all the organizers and the persons who are involved in this nice seminar on a good subject. Very good presentations were there. It included the technology. It included the your decision support system. It included the concept of drip irrigation, the latest inventions, the sensor-based irrigation, and the many cost reducing factors for irrigation. But actually, what I feel from this platform, I would like to give you a food for thought. You see, technology is never complete. We consider that drip irrigation is everything, micro irrigation is everything. This is a time where we must think over three important words. Those words are inclusion, inclusiveness, and integration. We have to get included with bigger systems. And what are the bigger systems? You know, in the world, you see, when we consider the irrigation, it is the surface irrigation which is highest, 85%, even right now. And after that, 12% is the pivot irrigation, and only 3% is micro irrigation. So we are beating our drum for the micro irrigation. Yes, we are 100% efficient, but we must think in an innovative way to get integrated with those systems which are higher in volumes, say pivot system. Why can't we develop some small pivot system, portable pivot system as per the need of the farmer? Small land holding is one issue. Society is one issue. Energy is one issue. Why don't we go for the micro system where energy requirement is very less, very less? You know, it should run totally by gravity, no pump, no pressure. So these are some of the elements on which the globe is considering. You might be happy to know that there is a concept which is coming out in the world from Israel. Now they are thinking to plan a micro irrigation system where nothing is required to be taken. Whatever existing infrastructure is there, maybe it's a channel, maybe half channel, full channel, wrong channel, all those infrastructures should be utilized in a way so that micro irrigation can be completed without giving a single horsepower for operating the system. Gravity fed system, that is called end drip. End drip is a new concept coming in the world. So now energy must be integrated with the water. Not only energy, society must be integrated with the water. And fourth, environment must be integrated with the water. So it is WEES, WEES, water, energy, environment, and society. Unless we integrate these four factors and design a system for the farmer, it will not give full profit. So I'm happy to see the presentations, but there are some issues those should be given to our entrepreneurs, our young engineers, our companies like Drip, the company Netafim and your Jain Irrigation. They must come out from their shell. Now things have gone. You cannot beat the same drum. You have to be innovative. You have to be completely new. Only sensor cannot solve the problem. You have to develop the sense. First comes sense, then comes sensor. Your sense should be perfect. So if your sense is perfect, then your sensor will work. So you must realize the global developments and develop a tailor-made system for our farmers. We are in the problem of small land holdings. Our holdings are only 0.1 to 0.2 hectare. We are not Israel. We are not Australia. We are not US. Our holdings are very small. Our economy is very low. Farmer does not have money. So why don't you develop some kind of small prototypes where farmer is given freedom to utilize their own resources, and drip system, sprinkler system, surface system, pivot system, let them have a hybrid kind of system where the farmer can get their own choice as per the region, local water supply. This is my one point that I would like to throw in this webinar at the end. And second is the water quality aspect. We have talked a lot about the water quantity. Okay, quantity is good, but quality is equally good because quality has direct correlation with the micronutrients, nutrient efficiency, and health and environment. So in irrigation, water quality should be given equal emphasis in the coming time. So those are the few words which I would like to render at this validity session. Time is limitation. So once again, I thank you, all the persons who are involved, and really Dr. Pundir, I personally thank you to involve this subject in your program of this, what you call this project, high education project. Thank you very much, sir. So nice of you to call me.
Thank you so much, sir, for sharing your innovative thoughts with us. Thank you. At last, I request Dr. Y.L. sir, for vote of thanks.
Thank you, Ayushi. Thank you, Ayushi. Respected and our most distinguished chief guest of the plenary session, Dr. M.L. Gaur, sir, Professor, Department of Agriculture Engineering, PA College of Agriculture. Our beloved Principal Investigator, Dr. R.S. Pundir, Dr. Gautam Patel, Associate Professor and Head of Department of Agriculture Economics, College of Agriculture, Vaso, and Nilesh Pawar, the Assistant Professor, Vaso, and dear participant. I deem it a great honor to propose a vote of thanks to our distinguished chief guest in the plenary, Dr. M.L. Gaur, sir. Sir, you have highlighted the issues which are going to be faced. In the next session, we can take care of such issues which will be helpful for the farmer at large. It deemed a great honor to our proposed vote of thanks who help us to making such webinar discerning success. First of all, I would like to thank all these speakers. Starting with our inauguration, I propose the hearty thanks to the Dr. Subhaiya for the inauguration. Thank you very much, sir, for interesting and provoking address. As well as I want to like in the first session, second session, we have Dr. Rang, Professor Head, Department of Soil and Water Engineering, College of Engineering Technology, Junagadh Agriculture. He described the design of drip irrigation system for the fertigation in the various crop in detail. Thank you very much, sir, for your address. I would like to thank our speaker in the third technical session. He is a senior agronomist in the Netafim irrigation system, Vadodara, Sri Prashant Bhai Pancholi. He delivered his lecture on the decision support system and advances in soil and water and plant-based micro-irrigation schedule. He has exposed the recent products in the irrigation segment, which will be going to be useful farmer at a large. In the he has shared the videos and everything. Thank you very much, Prashant. We can again try to utilize your services. I would also like to thank our last session speaker, Dr. K.C. Patel, Research Scientist, Micronutrient Research Unit, AU, Anand. He delivered a lecture on the concept and techniques of nutrient management, very in a precisely manner, in a very simple way. Thank you very much, sir, for your services. Yeah, I would like to express our program gratitude to our PI, Dr. R.S. Pundir, sir, for his guidance in this seminar. Sir, you have highlighted the issues as well as your cooperation is needed whenever you are always available. At the end, I would like to thank our beloved organizing secretary, Dr. Gautam Patel, for his planning and organizing event in the most efficient and effective skill he has shown, in particular in managerial side, how he's managed the whole event to sit in Vaso, and right now we are observing that. I would also like to thank the coordinator of all the events for making such seminar great success. Also, I would like to thank our team member from the College of Vaso, his principal and other staff member who directly indirectly helped to design this program, and they put their efforts. As well as I also would like to thank our capacity building group in the HRD in the NHEP cast for their support. Even I would like to thank all the participants as well as the director IT and their team for their supports and gratitude. Thank you very much. Jai Hind. Ayushi?
Yes, sir. Thank you so much, sir, for vote of thanks. Thank you all.
Hello. Okay.